Okay, these notes, because your polyatomic ion sheet went on page 22, right? So these notes are going to go on page 23 of your INB notebook. And it's called Criss Cross Method. Okay. Now, this is actually a little shortcut on figuring out your compounds. Okay. So let's get a picture of a periodic table first. Okay. Okay, and let's put that down here. Now you should have the charges for every single group, every single family on the top of your periodic table, right?
Yeah.
So let me show you what really happens and then I'll show you the shortcut. How about that?
Okay.
Okay, so let's do something like potassium. Potassium has what charge? A positive 1. Very good. And then let's do something like, let's do sulfur. And what's my charge for sulfur? Yep, a -2. Okay, so now when you combine these, remember we did the bonding? And you had to put the dots with empty space. Okay, now this is an ionic bond because you have a metal and a non-metal. Okay, so potassium's going to transfer those dots. But instead of doing all those Lewis dot structures, you can look at your oxidation number, in other words, your charge. So a +1 plus a -2 is going to give me how much? A -1. So that's not equal. So if I add another potassium with a +1, now I have +2 plus a -2. What does that give me? 0, right? Okay, so now I have what I would have had on the bonding. So I have K2 and S. That is my chemical formula. And that's without actually doing the bonding, right? Without doing all the dots in the empty space and where it's going to transfer. Okay, but let me show you a little easier way. Yep, easier than that. Okay, because I have K with a +1, I have S with a -2. Now, if they're the same number, they cancel out. You wouldn't have to do anything, and it would just be KS, right? Like, let's say K would have been a +2, right? But it's not the same thing. Can I reduce these two numbers? Forget about the charge for a minute. Can I reduce them any further? No, because of the 1, right? Very good. Okay, so they're going to criss-cross. Now, when this happens, it's no longer a charge. You're going to forget about the charge. So you have K, the 2 came down to the bottom, and you have S, and you don't really have to write a 1 because just the fact that the S is there means you have 1, right? Okay, so this, is this not the same thing as this? Is the exact same thing. Okay, so let's do something a little more difficult. Okay, let's do something like magnesium with a +2, and let's do nitrogen. What's my charge for nitrogen? -3. Very good. Now let's do it the old way versus the crisscross way, right? Okay, so a +2 plus a -3 would give me a -1. So that's not equal. So let's add magnesium. So now a +4 plus a -3 gives me how much?
1.
A +1, right? So that doesn't work out. So let's add another nitrogen. +4 plus a -6 gives me how much? Gives me a -2. So that's not equal. So let's add another magnesium. This is kind of like doing your Lewis dot bonding structures, okay? So now, a plus 6 plus a negative 6 gives me what? 0. Now is it all equal? Yes, it evens out. So how many magnesiums did it take?
3.
It took 3. And how many nitrogens did it take? It took 2, right? Okay, so now let's start with our original. We had magnesium with a plus 2. We had nitrogen with a negative 3. Bless you. Bless you. Now, are they the same number? Do they cancel out? No. Can I reduce these? Can 2 be divided into 3? No. So, we're going to Criss cross. Okay, so magnesium. Now, remember the number must be at the bottom. Anytime you have a number on top, it's a charge. And I always get, ma'am, well, you know what I meant. No, I don't. Because as a chemist, when I see this on the top, this means a charge. Okay? And when it's on the bottom, that means that that's how many elements you have. Okay? Is this not the same as this? It's going to work every time. Even if you have to reduce. Okay? Because those are the 3 questions you have to ask. Are they the same number? Like, let's do magnesium with a plus 2. And let's do... what is it? Selenium with a negative 2? Is it the same number? Yes. So they cancel out. All you have is magnesium and Se. Okay? That's it. That's your answer. Okay, so now, if I have something like... let's do lead. If I have Pb with a plus 4, and let's do selenium again, that's a negative 2. I think is selenium a negative 2? Yes? Okay. So now, are they the same number? Do they cancel out?
No.
No. Can I reduce?
Yes.
Yes. So 4 can be divided by 2 will give me 2. 2 divided by 2 will give me 1. Now I can crisscross the new numbers. So what is my chemical formula?
PB2SE.
PbSe2. Okay, remember that this goes across. Okay? You never give it down to itself. Okay? That would be wrong. All right? Good job. Okay, so what else? No, you reduce the numbers. Like you have a plus 4 and a minus 2. Let's say you had a plus 6 and a minus 2. You could reduce 6 divided by 2 is 3. 2 divided by 2 is 1. Remember, you have to divide by a common denominator. That's a good question. What was the other one, Melissa?
No, that was it.
We sure?
Yeah, that was it.
Okay, anything else? Okay, now that's for the first page. And anytime you have a metal that's a transitional metal, you could have different charges. So you're going to know what that charge is by the actual Roman numeral they're going to give you. So for today, this first one, I'm giving it to you. You see iron? It has a plus 2. So remember that some of these can have like a plus 2, a plus 3. Some will have a plus 1, a plus 2. And the Roman numeral tells you what it is. But before that, I want you to get used to just a crisscrossing, so I gave those to you on this sheet. So you're just going to give me the actual chemical formula. Now look at this one. What's different here? I'm giving it to you in names instead of the symbol, right? I want you to do this one first so you can get used to the crisscrossing. Okay? And we're going to grade this today. And then I want you to look at this. Pick one from the left side. I mean from the right side with the names. Number 4? No, from the right side.
Magnesium chloride.
Magnesium chloride. Okay, so you have magnesium chloride. Okay. What is magnesium?
Mg.
Mg. And Mg has what charge? You're going to look that at your periodic table, a plus 2. Okay, now we learned on Friday that IDE comes, it means it comes from the periodic table, right? Because that's the ending for a binary compound. So chloride is what?
Chlorine.
It's chlorine. And what's my charge for chlorine?
-1.
A -1. Very good. Now can I do my crisscross method?
Yes.
Yes. And so what's going to be my answer here?
Mg.
MgCl and then the 2. Remember that this number goes to the opposite side on the bottom. Okay? Huh? This is chloride. Okay. Yes? Where do we have a question here? Remember, your main objective is to make sure that you know how many elements you have of each element. Okay, and because all of these are binary compounds, you're going to only have 2 elements, but you have to know how many of each one you have. That's going to give you your chemical formula. Okay? And how are you going to know that? By looking at what?
Charges.
The charges. Very good, because the charges are going to tell you what to do. Whether you're going to cancel them, whether you're going to reduce them, or whether you're going to crisscross. Okay? Now, that's giving you the name. By the way, number 6, that's a group B element. It's a transitional element, zinc. Put a plus 2 on top of that one.
Which one?
Number 16, because they're giving you one with the transitional element. That's a plus 2. I think that's the only one. Okay, now look on the left side and pick one on the left.
RB2S.
YF3.
Okay, so let's look at number 6, RB2S. Now look on your periodic table. What's my... Now you're going kind of backwards. They're giving you the answer. This is what it crisscrossed to. So what was my original RB's charge? Yep, it was a plus 1. And what was my original charge for S? A -2, right? Okay, so now you're going to look on the periodic table. What was my name for RB?
Yeah, rubidium.
Okay, and let's spell that.
RUBID.
IDION. IUM. Okay, rubidium. Okay. And then S is what? Sulfur. Okay. Okay, and actually, because it's a binary compound, the ending is going to change. Very good. To sulfide. And so you must have that ending because it's a binary compound. Okay. Do we need to do another one of those?
So we just write the name down instead?
Right. So here you're gonna tell me what was the original name, because they're giving you the answer. They're giving you the chemical formula, right? So you're gonna tell me what was it originally. Remember that anytime you have a binary compound, that last element, it changes to IDE. That's what we did on Friday. Okay? Yes? Do we need to do another one of those? No? Yes? Okay, so pick one from the left side.
YF310.
YF3.
What number is that?
10.
Okay, number 10. Okay, Y, F, 3. Now remember here, you have a different objective. Instead of figuring out the chemical formula, you're figuring out the name, right? What was originally my Y's charge? A plus 3. Okay, and what's my original charge for F? A -1. So now, what is my name for Y?
Yttrium chloride.
Okay, now let's spell that. YITTRIUM. And where is that located? Is it in the S section, P section, D section? It's in the D section. Okay. And my charge is what? A plus 3. Anytime you land in the transitional elements where it's the D or F section, you're going to have a Roman numeral. That Roman numeral comes from the charge. So what's a Roman numeral for 3?
The 3 lines.
Yep. So iridium. And then F is what?
Fluoride.
Fluoride.
Yes.
And that's it. Okay. Now, for now, most of these are not in the Group B section. Most of them are in the A section. They're either the S's or the P's. Okay, part of the periodic table. So it's just going to be the name. But anytime you're in the transitional element, you're going to use the Roman numerals, especially for now. Some of them are always the same charge, and so those won't need a Roman numeral. But for now, let's go ahead and put a Roman numeral so we can get used to it. Okay? All right? We doing good?
Yes.
Yes? Do we have a question? No? Okay, go ahead and get started. Do this one first because we're going to grade this one right now. Okay?